let's take a look at finding the distance between 2 points. Looking at the directions here, we're first of all actually going to go ahead and do this in a graphic way so you can see it, and then we're going to wean ourselves off of the having to have a graph, and we'll take a look at it algebraically. But let's go ahead and plot these points. We're going to go over 4 and down 2. Okay, that's that point there. And then we're going to go -3 and -8. 1, 2, 3, 4, 5, 6, 7, 8. Now, when I look at the distance, it says find the exact distance. By the way, when it says exact, if we end up with any radical, in other words, any square root answer, we're going to leave it simplified, but we're not going to take a decimal approximation unless of course, it's a terminating decimal, things like that. We could go ahead and do that. So here we go. We're going to go ahead and look at the distance between these 2 points. Now, I could estimate the distance, but because it's going across the grid diagonally, it would be an estimate, and it says to find the exact. So I'm going to need to figure out a way to do this differently than just looking at it. So let's recall that we have a method of finding diagonal distances. If we remember about the Pythagorean theorem using right triangles, if you notice that I've created for myself a little right triangle, and if you remember back to your Algebra 1 days, we say that the Pythagorean theorem says that a squared plus b squared equals c squared, and that just means that a leg, we'll call this one a, and squared, plus another leg, we'll call that b squared, has to equal, if it's a right triangle, has to equal the hypotenuse squared. So we can pretty easily get the distance then by using this Pythagorean theorem. So let's go ahead and look here. If I want to look at the distance here, the length of this, 1, 2, 3, 4, 5, I have a length of 6. So that means my A is 6. I'm going to square that. And my B, let's see, we have a 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 squared, and that's going to have to equal the hypotenuse squared, which is always the side across from the 90-degree angle, which would be the C. So let's go ahead and finish this up. That's 36 plus 49. Now you can tell that this is going to be very, very easy to get. This is going to be 85 is equal to C squared. Now, we're going to obviously take the square root of both sides to get C alone, because that's my distance there, right? C is just C to the first power. So what we get is square root of 85. Now, you might be tempted to put that in the calculator and find the decimal approximation, but let me remind you, it's asking for the exact distance. So the next step would be to ask ourselves, hey, can 85 be broken down, and is there some kind of perfect square hiding in it? Well, my immediate thought is to divide by 5. Well, when I divide 85 by 5, I get 17, and so I notice that there's not a perfect square. Those are two prime numbers. There's not a perfect square hiding, waiting to be, to escape, and so then this is my final exact answer, the square root of 85. Now, I want to give us a connection to the way we can do this algebraically using the distance formula. So let's connect what we have here by doing this. I want to go ahead and label this point. This is 4, -2, and this point here is the -3, -8. Now, once they're labeled, now I'm going to go ahead and continue to label them, and I'm going to label this as X. I'm going to go ahead and call this X1 and Y1. In other words, this is my first point, and I'm going to call the coordinates X1, Y1. I'll call this one X2, Y2, meaning that's my second point. Now I want to find the distance between those 2 points. Well, thinking about the Pythagorean, let's take a look at this blue distance here. The blue distance was found by finding the distance between a -3 and a 4, basically on the x-axis and the number line. In other words, what is the distance between a -3 and a 4, right? So that's how we got the 7. So if I look at that, so let's look at all the ways that we could get a 7 by combining a -3 and a 4. So if I take the difference of those two numbers, if I said -3 minus 4, that would actually give me a -7. But if I take the 4 minus the -3, that would give me a +7. Now, let's take a look back. Let's let our visual image help us here. What did we have once we got the 7? We know we have to square it, right? So does it really matter whether we have a -7 or a +7? It doesn't really matter. And so what I can conclude then is this, that I could just go ahead and call this take the difference of the x's. Let's just take the difference of the x's and then square them. All right, take the difference of the x's. There's that x and there's that x coordinate. Take the difference of them and square them. All right, there's that. Now let's take the difference of the yellow, in other words, the distance of the yellow here over here. And what would that mean we would have to use? We would have to use or find the distance between them by using the -2 and the -8. Those are the heights of the places where my y value starts and stops, right? So I'm going to look at -2 and -8. Let's do the same thing with those, -2 and -8. How could I get this 6? Well, if I said -2 minus the -8, then I would get, that's a plus, that would give me a 6. But if I said -8 minus the -2, that would get me a -6. Now again, does it really matter whether I have a -6 or a +6? Because in the Pythagorean, we have to square the side. So again, it doesn't matter whether it's a negative or positive, so we could just say, hey, let's just take the difference of the y coordinates. So we write the difference of the y's. Now, it doesn't matter which you put first. Are you convinced about that? It doesn't matter if we put the 3 first or the 4 first on this one. Doesn't matter if we put the 2 first or the 8 first. So it doesn't matter the order because we're going to square it in the end. Okay, let's go ahead and finish the Pythagorean up. And so what do we get? We get the c squared, right? Okay, now what if I want to go ahead and clean up the c? Let's get the square root. And what do we have? We actually have the distance formula. Let me go ahead and write it for you. I'm actually going to make myself a little room here. Whoops. All right, I'm going to go ahead and, oops, come on now. Yep, ooh, excuse me. Well, I was going to move the 2 and the 8 information down a little bit, but that's okay. All right, we're going to go ahead and say this would be the distance, right? And so here's what we have for the distance formula. We have x2 minus x1 all squared plus y2 minus y1 all squared. And that's, if we take the square root of that, that gives us the distance between the 2 points, any 2 points. All right, let's go ahead and make sure that that formula is going to work for us, and we'll be finished. x2 was what? -8 minus x1, which is 4 squared. And this is going to equal the distance between them. Plus, now we go to the next thing, which is y2, -8 minus -2, and that's all squared. All right, let's just finish it up. So we have, this is a negative Oh, heavens. Sorry about that. 4 and a 3. That was supposed to be a 3. Pardon me. Negative 3 minus, okay, so we get the negative 7 squared. And we get a negative 6 squared. That's going to be equal to the distance. All right, we get 49 plus 36. And we get our 85, radical 85. Okay, so again, for this version here, we would not need a picture at all. We would just need to be able to label our points carefully. Okie doke, thanks for watching.